Okay, so hello everyone, welcoming you to Shorab Sir's classes and beginning with the third part of our discussion of the PEA paper, and we shall now begin with question number 6. So let us first have a look at the question. So it's basically which of the following is correct in a two good framework, and we are given some options with respect to diminishing utility and diminishing MRS. So now let us just get to the understanding first. So this is my question number 6. So if you remember in our basic diagram that we used to draw for our two good framework, it was something like this, right? Let's say the two goods are x1 and x2. So this is x1, this is x2. My indifference curves used to look something like this. And what does diminishing MRS mean? That the slope of the indifference curves gradually keeps on falling. So as you can see from these figures that the tangents are gradually becoming flatter, so the marginal rate of substitution gradually falls. So recollecting, so what essentially was my MRS? MRS is basically the absolute slope of the indifference curve. And what does diminishing MRS imply? That MRS falls as x1 increases. That is del MRS del x1 is actually negative. This is what the diminishing marginal rate of substitution means. And now when we come to diminishing utility for the two goods, coming to diminishing utility. What does it mean? For good 1, if I say, that means the marginal utility from consuming an additional unit of x1 is falling. So del mu1, del mu2, mu1 by del x1 is negative. And what does it imply for good 2? Del mu2 by del x2 is negative. These are the two things that are implied by diminishing utility. Diminishing marginal utility for the two goods x and y. This is what it implies. Now essentially the four options talk of some kind of a connection between these two. So we know one thing for sure, that what is the definition of MRS? It is mu1 by mu2, right? And we basically, if you look at the options carefully, we are basically trying to see that what conditions on the marginal utilities ensures diminishing marginal rate of substitution. Okay, so this is the thing that we are trying to see, and what is which one of it is necessary and what is the sufficient conditions, so to say. So MRS equals to mu1 by mu2. So I need to basically see that what condition on these two ensures this thing, right? So just for easy understanding, we can simply take log and take the differentiation derivative with respect to x1. Then what are we getting? If I take log, then log MRS equals to log of mu1 minus log of mu2. So 1 by MRS partial derivative of MRS with respect to x1 is equals to 1 by mu1 del mu1 by del x1 minus 1 by mu2 del mu2 by del x1. Now this part we can write it in a different way. Let me just show you what I'm basically trying to write. It's 1 by mu1. The first term remains because we exactly have the diminishing marginal utility structure that we wanted. So this is del mu1, right? But for good 2, I can write it in this way: 1 by mu2 dx2 by dx1. Sorry. Yeah, fine. It's correct. So it will be del mu2 by del x2. Okay. So if I just rewrite this statement, what we have got, it is 1 by mrs equal into del mrs by del x1 is equals to 1 by mu1 del mu1 by del x1 del mu1 by del x1 minus 1 by mu2 dx2 by dx1 del mu2 by del x2. This is the condition that we have got. Now basically we want to ensure that this part is negative. That means essentially the right hand side is negative. So what should be the condition on the right side? This is what we want to understand. So let us have a look at the options once more. So the first option says that diminishing marginal utility of both goods is sufficient for the diminishing marginal rate of substitution. That means for option 1, for option A, if you look at it, they are saying that these two should be negative. Then this will ensure that the left hand side is negative, but need not necessarily be, right? Because check over here that del mu2 by del x2, this part being negative, over here we have a minus. So this entire term over here will become positive. So negative and positive, it is possible that the answer becomes positive, right? So this is not necessarily true. Not necessary. Okay, so this is not necessary. For sufficient as well, that if, for what does sufficient mean? That both of them being negative ensures that this is del mrs by del x1 is negative, but this is also not the case. So just let me just correct it the way that I've written. It's not correct. So what is my initial statement? Diminishing marginal utility of both goods. So this is my first part of the statement, and the second part is diminishing MRS. So sufficient means diminishing marginal utility of both goods will ensure diminishing MRS, which is not the case. So this is not sufficient. It need not be the case. That is what I mean to say. It may be, it may not be. It depends on what the signs of the ultimate things are. Now similarly, taking a look at this one. Now part B. Diminishing marginal utility of both goods is necessary. So what does necessary mean? If I can just break the statement up, look at it. This is the first part of the statement, right? Diminishing marginal utility of both the goods. This is the first statement. Let's say it is statement capital A. And this part is the second statement, which is capital B. So what does necessary mean? What does a necessary condition mean? That B implies A. And what does a sufficient condition mean? That A implies B. So have a look at it. For the first one, I am repeating it once more, that for the sufficiency condition, A should imply B. That means diminishing marginal utility of both goods imply that diminishing MRS satisfies. Is this the case? No. Because if both of them are negative, the second term can be positive and that might lead to a positive term. So not true. Coming to option B, the second option. What does the second option tell us? It tells us to check the necessary condition. Necessary condition means B implies A. That means when there is diminishing marginal rate of substitution, both the goods have to be necessarily exhibiting diminishing MRS. That means if the left side is negative, both these two terms have to be negative. It may be, it may not be, right? We can't really judge. It's really, so this is not necessary as well. So not necessary. Coming to the third one, diminishing marginal utility of at least one good is necessary for diminishing marginal rate of substitution. Now look over here. The part C over here is diminishing marginal utility of at least one good. Now this is a little tricky part over here. Now let's say that one good that we are talking about is say x1. Then obviously del mu1 del x1 is negative, then the left hand side will become negative. That's for sure. But if x2 is negative, we can't say something like that. And if both are negative also, then we can't say something like that. So this part C, where we were supposed to check the necessary condition. So over here, what is my initial statement? This part of at least one good. And this is the second part, diminishing marginal utility. So what are we checking for necessary? B implies A. That means basically whether diminishing marginal rate of substitution ensures that at least one of the goods, diminishing marginal utility of at least one of the goods is negative, exhibits diminishing marginal utility. So that also can't be ensured. So essentially my option is, we are left with option number D. It's neither necessary nor sufficient. That's the answer. Now coming to question number 7. Now this is a straightforward question from theory. We know that the utility function representation is possible only when we have completeness and transitivity. Now you can see directly over here in the question only they have stated that the preferences are non-transitive. So utility function representation is never possible. That is option number D. Okay. Alright. So this is my solution to question number 7. Alright. So this concludes the part 3 of our discussion. For live, online and offline classes and complete study materials, past solutions and mock tests, you can contact the Saurabh Sir's classes. And I'm just putting down the number as well. You can contact us at 9836793076. Thank you.